Hello everyone, I hope you're having a great day. Today we're going to be learning our third and final way to solve systems. So you already learned last week solving by graphing, so we graphed both lines and see where they intersect at. We learned by substitution, where we isolated a variable and then substituted that value into the second equation. And now today we're going to be learning a third method, which is called elimination. And so for this method, we're going to follow these four basic steps. The first one is we're going to multiply one or both equations so at least one variable has opposite coefficients. And so what I mean by opposite coefficients, the opposite means they're opposite signs, so one's positive, the other's negative. And then that word coefficient just means the number in front of x or y. So I'm going to multiply one or both equations so that number in front of x or y are opposite coefficients. So let's say if I had, for example, 2x, the opposite coefficient would be negative 2x. My second step is to add your new equation to eliminate one variable. So the reason why we want opposite coefficients is because they will cancel each other out. So if you see, if I do 2x minus 2x, I get 0. And so that variable goes away. And then I can solve that remaining equation. So since a variable goes away, I have just one variable left over, and I can solve for that one. And then for my very last step, I want to substitute the value from step 3 into one of the original equations and solve for the other variable. So I'm going to substitute in, like for this one, let's say I had y equals 3, I would substitute that into either equation and solve for x. So let's go ahead and look at some examples. So I'm just going to start with ones that already have opposite coefficients so we can see how this process works. So I see here I have two equations. I want them lined up like this, where I have my x's first, my y's second, and then equal to a number. Or in other words, these are in standard form, if you remember that from chapter 3. And so I can see right here that my x's, the numbers in front, already have opposite coefficients. They're the same number, 3, but they're opposite signs. And so I see when I add these two equations together, 3x minus 3x, that cancels out. And then 2y plus 4y, I get 6y. 7 plus 5, I get 12. So I'm just adding these two equations together. And so now I see I have just one variable left, so I can go ahead and solve for that. So I can divide both sides by 6. And so I get that y is equal to 2. And now I'm going to do kind of the same last step that we did for substitution. I'm going to substitute this value in for y for either of these equations. So I want to go ahead and do this first one, this 3x plus 2y equals 7. And now I'm going to substitute this value in for y. So now I have 3x plus 2 times, well, y is just equal to 2, equals 7. 2 times 2, I get 4. Subtract 4 from both sides. So I get 3x equals 3. And then divide by 3, and I get that x is equal to 1. So I have my y, I have my x. For my final step, I need to write that as an ordered pair. My x first and my y second. Because you remember, all my answers for these are really an ordered pair because we're looking for where the two lines intersect when I graph it. Okay, let's try this again. So I see my x's already have opposite coefficients. They're both 4. One of them's negative, the other positive. But now I see something kind of weird happens with this one. So 4x minus 4x, that's 0, so those cancel. 4y minus 4y, that's 0, so those cancel. So I have nothing left on that side. And then negative 8 plus 8, I also get 0. So I get the answer 0 equals 0. Well, that's true. So if you recall from last week, that means that this one has infinitely many solutions. Okay, that's it for this video. You can go ahead and move on to the next one.